Alright, so in this video we're going to go ahead and continue our discussion on the fundamental theorem of calculus. We're going to start with this example here, which I'm asking you to find the integral from pi over 2 to x of cosine of t dt. And once you find that, then I'd like you to take the derivative. And you might be thinking, well, wait a second, I'm going to find the integral, which means I have to find the antiderivative, and then I'm going to take the derivative. And you might be thinking right now, well, this is kind of silly to do, but it'll lead us to some interesting things in just a bit, and we're going to see what we notice at the end. So let's go ahead and first start by finding the integral of this thing here. So I'm going to start by writing big capital F of x is going to equal the antiderivative of cosine of t. We know already is sine of t, and we are evaluating this from pi over 2 to x. And so again, using the first part of the fundamental theorem of calculus, we know that this is just simply equal to sine of x minus sine of pi over 2. And we can simplify this a little bit more. We know what sine of pi over 2 is. We have sine of x minus, and sine of pi over 2 is just 1. So what we're saying here is that f of x, big capital F of x, is just equal to sine of x minus 1, and that wasn't too hard to do. But now what we're going to do, is we're going to find the the derivative of big capital F. Well, here's our big capital F, and if I find the derivative here, well, the derivative of sine is cosine of x. The derivative of negative 1 or minus 1 is just 0. So we end up just having that f prime of x is equal to cosine of x. Now, what are some things that we notice here? Or what is it that we did? Well, we found the derivative of an integral. And if you notice what we ended up with cosine of x, which is really essentially what we have sitting inside our integral. The only difference here is that we have a function of t, but notice that when we evaluated this function with our limits, we ended up just substituting. We ended up substituting the x into here to just get cosine of x. And you might be thinking, well, didn't we substitute pi over 2? Well, yeah, we did. We did substitute the pi over 2 as well, but then when you take the derivative of any constant, you get 0, leaving you with just this substitution here. So this problem could have been reworded a different way. I could have asked you to find. So here's what we did. I asked you to find the integral. From pi over 2 to x of cosine of t dt. We found that first, and then I said, you know what? Once you find that, then take its derivative. Then find f prime. So I'm asking you to take its derivative. So this looks crazy. You're taking the derivative of an integral, but what did you get out? You got out, our final answer here was this cosine of x in orange. So let me change my color to orange here. So cosine of x. Well, my question to you is, how can we avoid doing all this mess and just go from here to here? And you might be thinking, well, hey, don't we just plug in? And essentially, yes, you do. I mean, there's a lot more going on. We essentially did all of this here, but I just wanted to show you that, look, if you're taking the derivative of an integral, we can simply just plug in the upper limit here. Given that this is a constant, we can plug in the upper limit here, and we would just have this function here, a function of t, is now, it's going to be the same exact function, but now it's going to be a function of x. And so the fundamental theorem, or part of the fundamental theorem of calculus, says this, that if we have the derivative, if you're asked to find the derivative of an integral from a to x, where a is just some constant, of some function whose independent variable is t, then you simply just get the same function f, but now all that happens is that you just substitute your upper limit x. Now there is a more general form, and you might be thinking, well, what if you have something more crazier than just x, and what if you have something a little bit more involved than just a constant? So for example, what if we were to have something that looks like this? So if I asked you to find the derivative d dx, and let's say now, instead of just a constant, let's say now that you have a function h of x, and up here you have another function g of x. So for example, you could have like x to the fifth and maybe like 5x squared up here, something like that. These are just different types of functions of x. And then you have your f of t dt sitting inside. And in the next video, we'll do an example of using this form here, but I just kind of want to throw it at you. Well, we do kind of exactly the same thing that we did above in the previous example. I take my limit, I take my upper limit, g of x, and I substitute it into my function so that I have f of, now what did I just substitute? Well, I'm plugging in this g of x. But you got to remember the chain rule here. I have to multiply by by the derivative that I just substituted into my function. So the derivative of g is simply g prime of x. And if you think about the example that we did above, you can think about plugging in the x here. So you can think about plugging in the x here and then multiplying by the derivative of x, which is just 1. But that's exactly what we did. And then imagine here, we had a minus, right? We had to plug in our bottom limit here. We did minus sine of pi over 2, minus sine of pi over 2. Well, here, in this example, I have to also substitute my bottom limit. So let me just highlight this in green. So h of x, I also have to substitute this bottom limit in there. So I'll have minus, and I'm going to have, well, let me go back to blue here, stay organized. Let's see. We have f of what we're about to plug in. Well, I'm plugging in an h of x. I'm plugging in a function h. I'm plugging in the function h, that's a function of x. But remember, by the chain rule, again, I have to multiply. I have to multiply by the derivative of what I just substitute, which is h prime of x. Now, in the next video, what we'll go ahead and do is we'll do a concrete example using the general form of this here.